The United Arab Emirates is facing a multi-trillion-dollar reality check. A failure of its power grid is not a possibility. It is an existential threat. Right now, millions of people live and work in a metropolis built to defy the sun, a city carved directly out of the Arabian desert, where summer temperatures make the outside air fundamentally unlivable. They survive entirely on one thing: uninterrupted power for uninterrupted air conditioning. And in the hottest months on record, that system is being pushed closer to its absolute limit than ever before. Not a brownout, not a rolling blackout, a cascade failure. This entire reality is built on a single fragile assumption. But what do you think is the biggest energy drain in a city like this? The skyscrapers or something else? Let me know in the comments below. So, the nation is building one of the largest solar power plants on the face of the earth. An ocean of glass and steel shimmering in the desert. An engineering gambit designed to sustain a future that can no longer rely on the past. It should be the final answer. But here's what the official plans don't tell you. The heat is getting worse, faster than any model predicted. The demand for power is growing in ways no one fully anticipated. And the desert itself is beginning to fight back. We uncover stories like this every week, the hidden engineering that keeps our world running, and the immense stakes when it fails. An incredible number of people watch these documentaries and just forget to hit subscribe. If you find this kind of deep dive valuable, please take a second to subscribe now. It's the single best way to support the channel and ensure you don't miss what's coming next. Let's begin. The real question isn't whether they can build enough solar panels, it's whether any amount of engineering can outrun a climate that is actively trying to erase the city from the map. Dubai was never meant to be. The city stands on the edge of the Rub al Khali, the empty quarter, the largest continuous sand desert in the world. This is a landscape defined by its hostility to life. Annual rainfall can be as low as 2 inches. Summer air temperatures routinely climb past 120 degrees Fahrenheit, a heat so complete it feels like a physical weight. The ground is sand, salt flats, and ancient sun-baked earth. There are no major rivers flowing through it, no freshwater lakes, no significant underground aquifers to tap. By every law of nature, this was a place for nomads and small trading posts, not a global metropolis of 3.5 million people. And yet, there it is. As late as the 1960s, Dubai was a small port town, its economy driven by pearl diving and coastal trade along the creek. Its skyline was low, courtyard houses designed for passive cooling, its population measured in the thousands. It was hot, quiet, and known to almost no one. Then they discovered oil, but unlike its neighbors, Dubai's reserves were modest. The oil would not last forever. It was a seed, not a permanent harvest. So its rulers made a decision that would alter geography itself. They would use the finite oil wealth to build something that would outlast it. A hub for trade, for finance, for tourism. A city so modern, so audacious, that the world would have no choice but to come. The skyscrapers began to rise from the sand. The mega malls, the luxury hotels, the man-made islands shaped like palm trees. And every single piece of this new reality was built on a foundational bargain. Cheap, abundant energy would make the uninhabitable habitable. Air conditioning would not be a luxury, it would be life support. The city's growth was a vertical line on a chart. It defied every projection, an appetite for ambition that planners had never seen and power system engineers had never been forced to confront. By the 1990s, Dubai was one of the fastest growing urban centers on the planet. By the 2010s, it was a symbol of hypermodernity itself. Today, Greater Dubai hosts a population that swells and contracts with millions of tourists and expatriate workers every year. All of them expect the lights to stay on. All of them expect the air to be cool. The city's peak electricity demand now regularly exceeds 10 gigawatts in the summer months. That is a truly colossal number. To put it in terms that mean something, that is more power than is consumed by the entire nation of Jordan, for one city. And it's a number that is growing by up to 6% every single year. Nearly 90% of that demand is for one purpose: cooling. Without it, the glass towers become solar ovens. The apartments become uninhabitable. The city, in a very real sense, simply stops. The Dubai Electricity and Water Authority, or DEWA, is the agency tasked with managing this relentless, escalating demand. Their entire operation is a war fought against physics every single day. A city of infinite ambition powered by a grid that has very finite limits, and those limits are now becoming dangerously visible. For decades, the answer to Dubai's power needs was simple, elegant, and buried underground: natural gas. The UAE sits on some of the world's largest natural gas reserves. It was abundant, relatively cheap, and far cleaner than burning coal. So they built a world-class network of power plants based on one of the most efficient technologies available: combined cycle gas turbines. These are not simple power stations. A CCGT plant is a masterpiece of thermal efficiency. It first burns natural gas in a turbine, like a jet engine, to spin a generator and produce electricity. But instead of wasting the immense heat that escapes, it captures that exhaust gas and uses it to boil water, creating steam. That steam then drives a second turbine, generating even more electricity. It's a 2-for-1 process that wrings every possible kilowatt out of each cubic foot of gas. The Jebel Ali Power and Desalination Complex, just south of the city, is the largest of its kind in the world. A sprawling industrial city in itself, a forest of smokestacks and turbines working around the clock. For a long time, this was enough. The gas flowed, the turbines spun, the city grew. But this solution was always carrying the seeds of a future problem. The first is that even the most efficient gas plant still produces carbon dioxide. Dubai's phenomenal growth was powered by a fossil fuel that was actively contributing to the warming of the planet. It was fueling the city while also fueling the very heat that the city was designed to escape, a perfect and terrifying feedback loop. The second problem is one of simple mathematics. Demand was beginning to outpace even the aggressive construction of new gas plants. With more skyscrapers, more residents, and hotter summers, the upward curve of power consumption was getting steeper. The reliance on a single fuel source, no matter how abundant, created a strategic vulnerability. A city this complex could not afford to be so dependent on one thing, and the world was changing. The Paris Agreement, the global push for decarbonization, these weren't just political headlines. They were signals that the era of unfettered fossil fuel expansion was coming to an end. Dubai, the city of the future, couldn't power itself with the fuel of the past. Not forever. The foundation was strong. It was also becoming a trap. Something else had to be built. Something at a scale the world had never seen before. This project is a massive bet on technology. But is a single giant solar park the right answer, or should they be focusing on something else entirely, like nuclear or decentralized power? I'm genuinely curious to hear what you think in the comments. The plan was not just ambitious, it was a statement. In 2012, DEWA announced the Mohammed bin Rashid Al Maktoum Solar Park, a project so large it is difficult to describe without resorting to hyperbole. Located deep in the desert miles south of the city, it began as a modest 13-megawatt pilot project. It was a test, a proof of concept. The test was successful. And then came the escalation. Phase 2 added 200 megawatts of photovoltaic panels. Phase 3 added another 800 megawatts. These are the traditional solar panels most people picture, flat panels of silicon that convert sunlight directly into electricity. But the true ambition, the part of the project that redefines what a solar plant can be, came with Phase 4. It was not just about making power when the sun was shining, it was about making power when it wasn't. Phase 4, also known as the Noor Energy 1 project, combines two different solar technologies. It has 250 megawatts of standard PV panels. But the centerpiece is 700 megawatts of concentrated solar power, or CSP. This is a different beast entirely. Instead of flat panels, a CSP plant uses a vast field of mirrors called heliostats to focus sunlight onto a single point. In this case, that point is the top of a central tower, a tower that now stands as the tallest solar tower on Earth. Inside the receiver at the top of this tower, the concentrated sunlight heats a fluid, in this case molten salt, to temperatures exceeding 1,000 degrees Fahrenheit. This superheated molten salt is then used to boil water, create steam, and drive a turbine, just like in a conventional gas or coal plant. But the genius of the system is what happens next. The molten salt isn't just used immediately, it is stored in massive insulated tanks. It becomes a thermal battery. It holds the sun's heat. This allows the plant to continue generating electricity at full power for up to 15 hours after the sun has gone down, providing stable, reliable power through the night. It solved solar energy's oldest problem, intermittency. It turned the sun into a 24/7 power source. The scale is staggering. Phase 4 alone covers 44 square kilometers. That is an area larger than many towns. The central tower is over 850 feet tall, visible from miles away, a concrete and steel monument to a new kind of energy. When all its phases are complete by 2030, the entire MBR Solar Park is planned to have a total capacity of 5,000 megawatts, 5 gigawatts. To put that in terms that means something, that is enough electricity to power more than 1.3 million homes and offset 6.5 million tons of carbon emissions every year. It represents an investment of over $13 billion, a direct replacement for multiple large-scale gas plants powered by an inexhaustible fuel source. The engineering challenges were immense. Construction crews worked in extreme desert heat. The logistics of transporting hundreds of thousands of mirrors and steel components into a remote desert location were a project in themselves. The precision required for the heliostat field is mind-bending. Each of the thousands of mirrors must track the sun perfectly throughout the day and focus its beam with pinpoint accuracy on the receiver atop the tower, miles away. A slight misalignment could damage equipment or reduce efficiency to zero. It is a ballet of robotics and software played out across a landscape of glass and steel. The project was hailed as a triumph, a demonstration of the UAE's commitment to a clean energy future. The impossible had been engineered. The solution was built. But the problem it was designed to solve was also changing. It was getting bigger, faster, and more complex than the architects of this grand solution had ever planned for. The desert itself was no longer a passive stage for this drama. It was becoming an active participant. The solar park is built. The gas plants are still running. The city is still growing. And none of it is truly enough. The delicate balance that keeps Dubai functioning is threatened by a series of interconnected problems that no single project, no matter how large, can solve on its own. The first is a simple feedback loop from which there is no easy escape. The hotter the climate gets, the more people rely on air conditioning. The more air conditioning runs, the more electricity is consumed. That increased demand puts more strain on the grid, requiring more power generation. And here is the brutal irony. The more power you generate, the more you contribute in some way to the very problem you're trying to solve. Even a solar park has a carbon footprint. The manufacturing of the panels, the production of the steel and concrete for the towers, the transportation, it all requires energy. And for now, much of that energy still comes from fossil fuels. Furthermore, air conditioning units don't just make the inside cool, they make the outside hotter. Every AC unit is a heat pump. It pulls thermal energy from inside a building and vents it into the surrounding air. In a dense urban environment with millions of units running simultaneously, this measurably raises the ambient temperature of the city itself, a phenomenon known as the urban heat island effect. Dubai is literally cooling its interiors by heating its exteriors, which in turn necessitates even more cooling. It's a vicious, self-perpetuating cycle. The second threat is the fragility of the grid itself. A modern power grid is the most complex machine ever built. It's a continent-spanning network of power plants, high-voltage transmission lines, and local distribution substations, all operating in perfect synchrony. Dubai's grid is state-of-the-art, but it is not immune to the laws of physics. Extreme heat is the enemy of electrical equipment. Transformers, which step down high-voltage power for local use, can overheat and fail. Transmission lines can sag in the heat, increasing the risk of faults. The massive demand during a summer heat wave puts every single component of the system under maximum stress. The danger is not a single failure, but a cascading one. Imagine a key substation failing on a 125-degree August afternoon. The load it was carrying is instantly shunted to other nearby substations, which are already running at their peak. This overload causes one of them to trip and go offline. Now its load is passed on, and the effect dominoes through the system faster than human operators can react. This is how a city goes dark. It's not a flicker, but a system-wide collapse. And as demand continues to rise every year, the buffer, the margin for error, gets thinner and thinner. But the most profound challenge, the one that ties everything together, is water. Dubai sits next to the ocean, yet it is one of the most water-scarce places on Earth. Nearly 100% of its municipal water is produced through desalination, primarily at the same Jebel Ali complex where it generates much of its power. Desalination is the process of taking seawater and stripping out the salt to make it drinkable. The most common method, reverse osmosis, is fundamentally an energy problem. It works by forcing salt water at extremely high pressure through a series of fine membranes. The pressures required are immense, and the pumps that create them are powered by electricity. A lot of it. The water-energy nexus in Dubai is not a theoretical concept. It is the central equation of survival. More people and more industry require more water. Producing more water requires more energy. Generating more energy often requires water for cooling. It is a closed loop, and both sides of the equation are escalating. The city is burning energy to make water so that people can survive the heat, a process that itself creates more heat. If you're finding this breakdown valuable, hitting the like button really helps the channel reach more people. And if you have family or friends who'd be fascinated by this, share it with them. Oh, and I know I've asked before, but a huge number of you watching still haven't subscribed. It's just one click, and it genuinely makes all the difference for us. Trust me, you don't want to miss the next one. The numbers are unforgiving. Desalination accounts for a significant portion of the country's total energy consumption. For every 2 gallons of seawater that enter a plant, only 1 gallon of fresh water is produced. The other gallon is returned to the ocean as a hot, super salty, chemical-laden brine, which has its own ecological consequences for the fragile marine environment of the Gulf. This relentless demand for both power and water has forced the UAE to think beyond just solar. Just down the coast from Dubai, in Abu Dhabi, the nation has built the Arab world's first nuclear power plant. The Baraka facility, when fully operational, will provide up to 25% of the country's electricity needs with zero carbon emissions. It is another monumental engineering feat, a powerful and reliable source of baseload power that operates 24/7 regardless of the weather. It is a critical piece of the puzzle. But even nuclear power is not a panacea.